Hello, this is Mr. Passon. Today we're going to be talking about proportionality in tables and graphs. That's our Friday lesson here. Remember that our notebook check is coming up, so go ahead and click on this link here. Then you should see the link for the notes. And we're going to make a copy of those slides here. And I accidentally filled in something ahead of time. I'm going to delete that so we can get to it at the right time. It also looks like I forgot to shade a couple boxes. So, alright, first go ahead and put in your name and the date. I'm going to go ahead and change the view so we can see this a little bit better. Zoom 200%. Good. So, we're talking about proportionality in tables, and then we're going to talk about proportionality in graphs. Relationships are proportional. Oh, help if I get that right. If they can be represented by the equation, we figured that last time, y equals k times x. Now, often we're actually going to ignore the multiplication symbol and just write y equals kx. Anytime we've got a number next to a letter, or a letter next to a letter, we're going to assume that that means multiply, where k represents our constant of proportionality. So now we're going to deal with this example. We're going to see some applications of this in both a table, and then later we're going to get into graphs. There are two coffee shops in town that charge different prices. Their prices are proportional. That means this ratio has got to always be constant. Alright, but some of the information is missing from their price list. So we're going to go ahead and take a look at their price list, and we're going to see if we can figure out the missing information. Alright, so we already know for here that 3 cups of coffee cost $8.25. We should be able to go back and divide to get the price of 1 cup of coffee. Okay, so let's go ahead and do $8.25 divided by 3. I'm going to grab my pencil here, and I'm going to do that calculation sort of off to the side here. 8.25, and we're going to divide by 3. Well, 3 goes into 8 2 times. That's 6. When we subtract, we get 2. Bring down the 2, so we get 7. It's 21. Subtract, we get 1, 5. And that goes in 5 times. So here we get that 1 cup of coffee costs $2.75. So again, that ratio should always be the same, so we can go ahead and fill in $2.75 for each one of these. That's what we mean when we say that it is proportional. The ratio is always the same. Now we can go back and figure out, well, we're going to do $2.75 times 1 to get the cost of 1 cup of coffee. $2.75 times 2 to get 2 cups of coffee. Or we could just add our previous cup to this one, so it's going to be $5.50. Then we get $8.25, then we add another $2.75, and that's going to be $11. Right? Then we're going to keep going, so then we've got our $13.75. And then we're going to get $16.50. Now, let's look at the other coffee shop. Here we know 2 cups of coffee cost $5.60. Note that this is 10 cents more, and we divide that over the 2 cups. That's 5 cents more per cup. So this one is $2.80 per cup. And again, it says it's proportional, so we know all of them in this ratio are 2.80. Now, not everyone prices their stuff this way, where each cup costs the same amount, but it is a pretty common way. Okay, so now we know our first cup is $2.80. Then these are always going up by 1, so we can add $2.80 each time, or we could do $2.80 times 3, $2.80 times 4, $2.80 times 5 to get our different answers. Oh, not $11. What am I doing? I'm reading the wrong one. $11.20. and then we're going to have $14. $14 even. And then $16.80. Alright? So, what do you notice that is different? Well, the ratio is different. Right? The constant of proportionality is different. Alright. Now, in this case, we could say Seattle Coffee Works is 5 cents cheaper per cup. What proved that both coffee shops sell their drinks at proportional rates? The fact that the ratio is always the same. So if the ratio was not the same, it would not be proportional. Now, if you were to purchase coffee at Houndstooth Coffee, how much more would you pay than if you paid to purchase 9 cups of coffee at Seattle Coffee Works? Well, it's 5 cents more per cup, so it's going to be 0.05 times 9, which is 45 cents. Let's go ahead and put that money symbol in there. Oh, not there, but there. So it's 5 cents times 9 cups, so 45 cents more. Alright. I'm going to clear out my drawings. And we're going to look at this one. A third coffee shop is opening up in a busy business district. What do you notice about their pricing structure? So, y over x is $2.90. Now let's try 570 divided by 2. Well, that's not $2.90, that's actually $2.85. And then, let's see, 840, well that's divided by 3, so that's going to be $2.80. Then 11 divided by 4 is going to be $2.75. And then 1350 divided by 5 is $2.70. So the ratio is not the same here. Alright? So, it is not proportional. In fact, it decreases as you purchase more. So the cost per cup decreases as you purchase more. What would benefit you in this structure? Like, where is it then cheaper than here? So if you buy 5 cups of coffee or more, then Stumptown is cheaper. Alright. Now, let's go ahead and go on to page 2. Okay, use your understanding of the constant of proportionality to determine K. If the relationship is not constant, or does not have a constant of proportionality, label it non-proportional. So we're going to look at y over x for each one of these. Now, I'm going to grab a little spreadsheet here because that allows me to do my divisions real easily. So I'm going to go ahead and think about my 6.8 divided by 2. And then I'm going to get 17 divided by 5. And then I'm going to get 27.2 divided by 8. And then 37.4 divided by 11. So we look at this, we see we get 3.4 every time. Therefore, it is proportional, and we can say y equals 3.4 times x. And remember that we do not need the multiplication symbol in there, so we could just write y equals 3.4x. let's go ahead and take a look at our next one. So here we've got 3 divided by 1. Oh, I have to put a little symbol in there to make sure it can. Why is that? Oh, that's a date now. Three divided by 1 is 3. 9 divided by 4 is not 3. So suddenly, these ones, the ratio is not the same. It is not proportional. Let's look at this one. We've got 18 divided by 3 is 6. 30 divided by 5 is 6. 42 divided by 7 is 6. And 54 divided by 9 is 6. So we get y equals 6 times x. So if you give me a number here, I multiply it by 6, I get this number here. Alright. So a fraction can also represent our constant of proportionality. Now, let's go ahead and see if we can figure out the work here. I accidentally already showed you the answer. So we're going to think of this as our x. So let me go ahead and grab a text box here. Let's put x here. And our y here. So our first fraction would be 1/3 divided by 1. Our next fraction would be, and we can think about that ratio, so that'd be 1/3 times our reciprocal of 1 is 1 over 1, and that's going to equal 1/3. Alright, let's try our another one, 4/3 divided by 4. Well, we're going to think of that as 4 over 1. So now we're going to use keep, change, flip, and we're going to have 4/3 times 1/4. And we multiply the tops, we get 4 over 12, which still equals 1/3. So we get a constant of proportionality, our k, equals 1/3. Alright? For each table shows a proportional relationship, so we know the ratio already exists. So first thing we want to do is we want to calculate the ratio, figure out our k, and then we can go back and fill in the rest of our table. So here I'm going to take 78 divided by 13, and we get that our ratio is 6. So to get from here to here, we need to multiply by 6. So this one is going to be 60, and this one is going to be 6. To go backwards, we need to divide by 6. So 24 divided by 6 is 4, and 42 divided by 6 is 7. Let's find our constant of proportionality here. We're going to take 15 divided by 6. Let me go ahead and that we get 2.5, so our k is 2.5. And so to get the number here, we need to divide by 2.5. So let's take our 60 divided by 2.5. Would help if I remember to put in the equal sign there to know that I was supposed to do the calculation. So this one is 24, not that one, that one. And then 70 divided by 2.5 is going to be 28. Here we're allowed to make up any number that we want, so I'm going to say 10. 10 times 2.5 is 25. Now here, again, let's see. So all the time I've been assuming, and it's actually a pretty reasonable assumption, that x is coming first and then y is coming second. So let's go ahead and formalize that by writing it's x, then y. And then I'm going to grab this one, Control-C-V, move this one here, Control-C-V, move this one here, Control-C-V. So we're always thinking about it as the ratio of this one over this one. So here's the ones where we can compare, and we're going to do 12 divided by 15. Now that comes out to be a decimal. Oh, it would help if I did it right. So let's do 12 divided by 15, and we get 0.8, which is also 4/5. So you could do 0.8, but you could also write it as 4 over 5. Now, for a lot of the things we're going to be doing, the ratio, the written as a fraction, is going to be a lot more convenient than the decimal. Okay? So now, to take this number and get back here, we actually need to divide by 4/5, which is multiplying by 5/4. Alright? So we're going to take 4, so this one is 5. Now we can double this number, so this number doubles to get here, so this number doubles to get here, so this is going to be 10. And then we can make up any number that we want here. I'm going to go ahead and just put in 20, and 20 times 4/5 is going to be 16. This one, here's the relationship that we're going to find. So we're going to take 84 divided by 28. And we get 3. So that means to get up here, we're going to multiply by 3. So this one is 105. To get this way, we're going to divide by 3. So this is 21. And this is, what, 10, 14? Then this one is going to be 7 times 3 is 21. So our constant of proportionality is 3.